Today's presentation discusses the role of microbes in domestic wastewater treatment and the Malaysian regulatory framework, in line with Sustainable Development Goal 6, clean water and sanitation. And these are the group members for today's presentation. Water is an essential resource for life, but not all water is clean. Every day, human activities produce wastewater that contains harmful pollutants. Without proper treatment, this wastewater can contaminate rivers, lakes, and groundwater. This is why wastewater treatment plays an important role in protecting water. Wastewater is water that has been used and contains pollutants, either from domestic, industrial, or agricultural sources. Common sources include household activities like bathing, washing, and cooking, as well as industrial processes and agricultural runoff. If not treated properly, wastewater can harm the environment and public health. Wastewater treatment is the process of removing contaminants from used water to make it safe for discharge back into the environment or for reuse. It is necessary because untreated wastewater contains harmful substances, including chemicals and pathogens, which can pollute water bodies, affect ecosystems, and pose health risks to humans and animals. Wastewater treatment is closely linked to Sustainable Development Goal 6, which aims to ensure availability and sustainable management of water and sanitation for all. Proper treatment of wastewater helps provide safe water, protect ecosystems, and promote public health, contributing directly to achieving this goal. This slide highlights common issues in domestic wastewater treatment, including poor system design and weak operational control. Many systems cannot handle wastewater volume and composition, leading to ineffective treatment. And it causes water pollution, eutrophication, and public health risks such as waterborne diseases. To overcome these problems, microbial technology uses specific microorganisms like Pseudomonas, Bacillus, and Nitrosomonas to break down organic pollutants and remove nutrients such as nitrogen, ensuring efficient, sustainable, and regulation-compliant treatment. The objectives of this report are to explain the main stages of wastewater treatment, from preliminary to sludge treatment, and to highlight the role of microbes at each stage. The report also discusses how microbial processes support nutrient removal and ensure compliance with Malaysian environmental regulations, including the Environmental Quality Act, sewage and industrial effluent regulations, and the National Water Quality Standards. This slide shows the overall wastewater treatment process, which includes preliminary, primary, secondary, tertiary, and sludge treatment stages. Preliminary treatment is the first stage and acts as a physical barrier to protect downstream systems. Bar screens remove large debris, while grit chambers remove sand and gravel by gravity. And there is no microbes are used at this stage, but it ensures better performance of biological treatment later by protecting microbial biomass and improving oxygen transfer efficiency. This stage supports compliance with the Environmental Quality, Sewage, Regulations 2009 and the Environmental Quality Act 1974 by reducing pollution at the source. Primary treatment removes settlable solids and fats, oils, and grease through sedimentation and scum removal in primary clarifiers. About 50% to 70% of suspended solids settle as primary sludge, and indigenous microorganisms are removed together with the solids, while hydrolysis begins to prepare wastewater for secondary treatment. This stage reduces BOD and COD load, protects secondary treatment processes, and ensures compliance with DOE limits and the Environmental Quality, Scheduled Wastes, Regulations 2005. Secondary treatment focuses on reducing COD and BOD using biological processes after primary treatment. Aerobic microbes decompose dissolved organic waste into inorganic compounds and solid biomass that can be removed. The main processes include digestion, activated sludge, where pollutants are broken down into safer solids, and trickling filters, which use biofilms to degrade organic matter. To comply with regulations, BOD and COD levels must meet the standards set under the Environmental Quality Act, EQA, 1974, as a legal discharge can result in fines and penalties. After that, tertiary treatment is carried out to further purify the wastewater before discharge. This stage removes remaining sludge and pathogens through filtration and disinfection. Disinfection methods include chlorination, UV treatment, and ozone treatment. Denitrifying bacteria are used to remove excess nitrogen and prevent algal blooms. Under the Environmental Quality, Sewage, Regulations 2009, sludge discharge into Malaysian waters is prohibited, and DOE approval is required for land disposal. Lastly, sludge treatment aims to stabilize solids and remove contaminants such as heavy metals. Fermentative bacteria break down complex organic matter, while processes like thickening and digestion occur through hydrolysis, acidogenesis, and methanogenesis. Failure to meet discharge standards may result in fines, imprisonment, and mandatory remediation under the Environmental Quality Act 1974. In conclusion, wastewater treatment is important to protect public health and the environment. As urbanization and industrial activities increase, more wastewater is produced. Microbial technology helps break down organic pollutants effectively. Proper treatment ensures wastewater is safe before discharge and supports Sustainable Development Goal 6, clean water and sanitation. That's all from us, thank you.